Today we're going to be talking about changing fractions into decimals by using long division. Now, an important part of being able to do long division is being able to use our multiplication tables. So if you don't have your multiplication table, or even if you do, what I'd like you to do is on the back of your notes, you have a blank multiplication table. Go ahead and fill that in. This is going to be essential for us to be able to do what we need to do with long division. If you need to, pause the video now so you can go ahead and fill in your multiplication chart now. Now that you have your multiplication chart filled in, what we want to do is we want to change 3/8, the fraction, into a decimal. And we have a couple of steps. Step 1 is rewrite as a division problem. Now on this part of the SOL, we don't have a calculator. That's why it's essential for you to have your multiplication table. And at the very beginning of the SOL test, what we should do is fill out, on graph paper, fill out our multiplication table. So the first thing, again, it says rewrite as a division problem. The numerator is always the dividend. The denominator is always the divisor. So what we're going to say is 3 divided by 8. Okay, 3 is the dividend, 8 is the divisor. That means we're trying to divide 8 into 3. So as step 2 says, divide 3 by 8. Since 8 can't go into 3, we have to add another 0. Now it says after the decimal, well, I don't see a decimal here. It's understood that the decimal is right here after 3, and I'm going to put it up on top of the bar as well. And now I can add my 0. Now I can figure out how many 8s go into 30. Again, this is where your multiplication table comes in. If we look at the back, of your paper, we go over to 8, and I'm going to go over and I see 24 and 32. 32 is too big, so I'm not going to use that number, so I'm going to go to 24, and 8 goes into 24 3 times. So I'm going to go ahead and put a 3 up here. 3 times 8 makes 24. That decimal is kind of like a placeholder to help us out at the beginning. It's not something we necessarily need right now. So 30 minus 24 will end up with 6. I'm going to extend this fraction bar a little bit because I'm probably going to need to add a couple more zeros. I haven't been able to clear it out here at the bottom yet. So I'm going to put another 0 in, and I can bring that 0 down where I have 60. Now I need to figure out how many times 8 can go into the number 60. Again, going back to my multiplication chart, I'm going across from my 8, 40, 48, 56, 64, too big. 56, 7 times 8 makes 56. So I'm going to go back, and I'll put a 7 here. 7 times 8 makes 56. 60 minus 56 is going to give me 4. This isn't cleared out at the bottom yet, so I'm going to add another 0. And I look at my that 0 comes down. You might know already what number should go up there, but let's go and double check. Let's see. Clear this out so we have some clean space to look at. 8, and I'm going to go over. Here's my 40 right here. So 8 times 5 gives me 40. So I'm going to go ahead and say 5. 5 times 8 is 40. Since 40 minus 40 is 0, my answer is going to be 0.375. We want to keep that 0 in front of the decimal as our placeholder. So let's go ahead and practice this skill with a couple more fractions. First, I have 4/18. So I'm going to say 4 divided by 18. Well, I don't have 18 on my multiplication chart back here. So it might think that, okay, we can't do it because we don't have 18s. Well, for some of us, we figured out our multiplication chart simply by adding. We added another 12 to 12 and got 24, and added another 12 to 24 to get 36. So if we need to, let's just go ahead and put in a line for 18s. I'm going to put 18 times 1 is 18. That's easy. And I added 18 and I got 36. And then I added another 18 and I got 54. And I added another 18 and I got 72. And then I added another 18 and I got 90. And I added another 18 and I got 108. And another 18, 126. And if you want to check my math, please pause and double check it. Please. 144, 162, 180, 198, and 216. So I just added a row for my 18s just in case I need it. So now I'm going to go and go back and see, I put my decimal here. I'll put a 0 in. Now I want to figure out how many times 18 can go into 40. So I look at my multiplication chart and I see 18 and I go over and there's 30. 54 is too big, so I want to go all the way up, and that's 2 times. So I'll say 18 times 2. 18 times 2 was 36. 40 minus 36 is 4. I'm going to put a 0 in as a placeholder, bring that down, and it's another 40. I forgot my decimal there. It's another 40. Well, I know that it's going to be 2 again, and I have 2 times 18, 36, another 4. Well, it looks like that this is going to be a repeating decimal. I can keep doing this over and over and over again, and I'm still going to end up with 2. It's going to be 0.22222. So my answer is going to be 0.2 repeating. That's my answer. Now, 4/18 can be reduced. We didn't reduce it, but 4/18 we can divide the numerator and the denominator both by 2, and we'll end up with 2 over 9. Whenever I have a number over 9, that's a pattern right there, because 1/9, 2/9, and you can check it on a calculator if you want, 3/9, 4/9, 5/9, all the way up to 8/9 is going to equal that number repeating. That number, excuse me, I forgot my 0 as my placeholder, that number repeating. That number repeating, the numerator repeating. See the pattern? So that's just something we want to keep in mind. It's just a special rule when we're dealing with ninths. So keep that in mind whenever you're dealing with ninths. Now 9/25. I don't need to go ahead and do anything on my multiplication table for 9/25 because I know 25 can go into 100. So I'm going to multiply my numerator and my denominator both by 4. 25 times 4 is 100. 9 times 4, if you forgot, we'll go down to 9 over 1, 2, 3, 4. It's 36. So we have 36 hundredths. Right there, that is our decimal. We write it the way we see it. It would be 0.36, 36 hundredths. It's been changed into decimal form. Now, 6/7. I have 6 divided by 7. I want to put my decimal in as my placeholder. 7 goes into 60. Let's see. 7, go over. 63 is too much. 56 is right. It's going to be 8. So I have 8. 8 times 7, that's going to be 56, as we saw on our multiplication chart. We subtract, we end up with 4. Write a 0, bring it down. 7 goes into 40. Now I know 7 times 5 is 35, so I'm going to go ahead and put that there. 5 times 7 is going to be 35. I end up with a 5. Put another 0 as a placeholder. Bring it down. Now, 7 goes into 50. Let's see. Well, I know 7, we just talked about perfect squares. So I know 7 times 7 is 49. 50 minus 49 is 1. Put in another 0. Bring it down. Here's my 0 here. 7 goes into 10. 1 time. 1 times 7 is 7. Go ahead. I have 3. Put a 0 as a placeholder. Bring it down. I have 30. 7 goes into 30. Let's see. Going on over. Here's my 28. 7 goes into 30 4 times. So I have my 4. 4 times 7, that's going to be 28. And 30 minus 28 is 2. Another 0, bring it down. 7 is going to go into 20. That's only going to be 2 times, because 7 times 3 is 21. 2 times 7, that's going to be 14. And there's a 6. Okay. We could keep doing this on and on and on and on. Generally, we only want to go out 3 decimal places, and then we would probably round. But what I wanted you to see here is if I was to put another 0 in, bring it down, I would start off with 60. This is the number I started off with before. This is a repeating decimal. So we don't want to continue doing this over and over again, because basically your answer is going to be 0.857142, 857,142, 857,142 over and over and over again. So I'm going to go ahead and round this decimal off. And I'm going to go ahead and say the answer is 0.857, and just leave it at that. We have additional numbers if we need, but I don't think we need to do that. So if you have any questions at all, please go ahead and write them here in this rectangle. Thank you.